Hi, for this video what I want to do is talk to you about analyzing and graphing rational functions. There are a lot of different scenarios that can happen in graphing rational functions. That's why I'm doing several examples of this. Okay, for this particular one, what we have is f of x equals 6x squared plus 7x minus 3 over 3x plus 2. I went ahead for time's sake and factored the top part out. You do want to see if you can factor it to see if you can simplify, but this one, nothing simplifies in the numerator and the denominator. Okay, so for this particular one, it's already in simplified form, but you always want to check to make sure. So in order to analyze, what we're going to go through and do is we're going to state the domain, we're going to find any vertical asymptotes or holes, and we're going to find horizontal or oblique asymptotes, and we're going to find intercepts, and then we will graph it from finding all of the information that we did. It is possible that a graph will not have any x-intercepts or y-intercepts. It's also possible that it won't have vertical asymptotes or holes. It's also possible that it won't have horizontal or oblique asymptotes. There's a lot of situations that can happen, okay, like I said. So with this, the first thing that we want to do is state the domain. We want to know what values of x will work. So for A, the domain is always whatever makes any value except for what makes the denominator equal to 0 is okay to work in the domain. So we would start with setting 3x plus 2 equal to 0. And we would solve this equation. So if we move the 2 over, it becomes negative 2. And if we divide by 3, that gives us negative 2/3. So this is telling us that x cannot equal negative 2/3. Okay, so my domain would be all values of x such that x cannot equal negative 2/3. So this would be my final answer, okay, for part A. So the domain is all values of x such that x does not equal negative 2/3. To find the vertical asymptotes come directly from the domain or the holes. If it cancels out, then you have a hole. If it doesn't cancel out, you have a vertical asymptote. So in this case, we would just have a vertical asymptote. So for part B, we would just have a vertical asymptote at the point x equals negative 2/3. Okay, so if we want to go ahead and put that on our graph, we could come over here and we could draw a vertical line at negative 2/3. And this tells me that that is a restriction in our domain, that x cannot equal this. Okay, vertical asymptotes can never be crossed. Horizontal and oblique asymptotes can be crossed. Okay, so let's talk about the next one. The next thing that we're going to talk about is horizontal or oblique. And the way that you tell is you look at the degree of the numerator and the degree of the denominator. So for this one, because the degree of the numerator is 1 more than the degree of the denominator, that tells us that we're going to have an oblique asymptote. So for part C, this one will have an oblique asymptote. Since the degree of numerator is 1 more than degree of the denominator. So anytime this happens, we have an oblique asymptote. And the oblique asymptote can be found by doing long division of this expression. So I would take the 3x plus 2 and put it on the outside. So the denominator goes on the outside and the numerator goes on the inside. So I would have 6x squared plus 7x minus 3. If it was more than 1, so like if the degree of the numerator was like 2 more than the degree of the denominator, then you're going to have a curved asymptote, which is more complicated. So for this one, we're just going to go with an oblique asymptote since the degree of the numerator is exactly 1 more than the degree of the denominator. So to do long division, remember what you do is you figure out what would I multiply 3x by to get 6x squared. So I need 2 times 3 would give me the 6, and x times x would give me x squared. And then what we do is we take this value and we distribute it into this expression. So we would have 6x squared plus 4x. And then if you remember from just long division in elementary school, we always subtract. So we would have 3x and we would bring down the -3. And then again, we just look at the first number. So we only look at the first number and we would figure out what would I multiply 3x by to get 3x, and that would be +1. So if I multiply that through, that gives me 3x plus 2. And if I subtract these values, I have a remainder of -5. So when it asks for the oblique asymptote is going to be at y equals 2x plus 1. Okay, so this is a slanted asymptote, and like I said, your graph can cross it. This one doesn't happen to, but it can cross it. So the oblique asymptote, we would start at 1 on our y-axis, and then we would use our slope to go up 2 over 1 to get some points, up 2 over 1. Or I could have gone down 2, back 1. I'm just drawing several points just to help me draw a straighter line, because on here sometimes I have a hard time drawing a straight line. And so then we would just do our oblique asymptote goes through these points. Okay, and then the last thing that we want to find is we want to see if it has any intercepts. I know I'm kind of graphing as we're going. Sometimes it helps a little bit. Okay, so for our intercepts, what we're going to do, the x-intercepts can be found by setting the numerator equal to 0. So if we go back up to our equation up here, our numerator, I'm going to just take the factored form because it will make it easier for us. So I'm going to take the numerator in simplified form, the 3x minus 1, 2x plus 3. And I'm going to set this equal to 0. So if I set both of these equal to 0, either 3x minus 1 equals 0, or 2x plus 3 equals 0. Since nothing's simplified, we don't have any holes, so we don't have to worry about any restrictions. So we would end up with x equals 1/3, or x equals -3/2. So I'm going to go ahead and go put points at those because we know that there are no restrictions. So that tells us, if I write this, let me write this in the correct notation. So this would be 1/3, comma 0, -3/2, comma 0. And I'm going to go ahead and put my x-intercepts on my graph. I definitely need to get a bigger screen to make this easier when the problems get a little more complicated. Okay, so x equals -3/2 is -1.5, so we know that we have one that crosses here. And then we also know that we have an x-intercept at 1/3, 0, so our other intercept would be on this side. So that's telling us that something's going to happen here and something's going to happen here. Okay, the last thing that we want to look at is the y-intercept. Okay, and the y-intercept is what we get when we plug in 0 for x. So we want to find f of 0 in our original function. And since our original function was, I'll just write it down here so that you guys have it again, is 6x squared plus 7x minus 3 over 3x plus 2. So basically what's going to happen, if I plug in a 0 for this, it's going to cancel out. A 0 for this is going to cancel out, and a 0 for this is going to cancel out, and we're just left with -3/2. Okay, so if I come up to my graph and I put my point on here, we get -3/2, which is -1.5. So that tells me that this part is going to get closer and closer here, and then it's going to come up here. Okay, for the other one, if you wanted to, you could go ahead and plug in some points, but if you're just drawing a rough sketch, we know it's going to go in here and it's going to get closer and closer this way, and this one's going to come down here and get closer and closer this way. Okay, for these, it's a lot harder to be precise because of the fact that you're dealing with fractions, but you can at least kind of figure out which sectors it's going to be in. Like I said at the beginning, these can be very complicated. There's a lot of different scenarios that can happen, and so a lot of times I'll just plug it into my graphing calculator to make sure that it's graphed correctly with all the points and get the points directly from there, rather than taking the time to plug in values for x into my original function. So it's always easier just to be able to find your intercepts, find your oblique asymptotes so you kind of know the direction. It will give you ideas of which sides they're going to be in. And then you can also pick values if you wanted to. Like I could take -1 and plug it in and see what it gives me into this equation, but I just gave you a rough sketch. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know as well.